not necessary that all the times we have a resistance combinations purely in parallel combinations or purely they are in series. There could be a mixed combinations also, that is some of the resistors they are in series and some they are in parallel, and it may happen that is none of the resistors they are in series and parallel. So let's take the first case where we have a mixed combination of resistances which are in series also and some they are in parallel also. So over here if we see, we have a 20 volt battery. This is once again a linear circuit. Linear circuit is where we have all the ohmic resistors only. So over here we have a 20 volt battery, and this 5 ohm and 2 ohm resistors they are there, and this 4 ohm, 7 ohm, 5 ohm resistors they are here. We have to find, number one, what is the equivalent resistance of the circuit. First of all, let's see if we have any resistances they are in series or not. So over here we see the conventional current which flows, whatsoever current flows through 5 ohm will be flowing through the 2 ohm resistor also. They are joined end to end. So it means 5 ohm and 2 ohm they are in series. So 5 plus 2, we know that is when the resistors they are in series, we can simply add them. So what we can do is, between A and B, we can remove this 5 and 2 ohm resistor and we can replace them by one single 7 ohm resistor, that is equivalent resistance of these two is 7 ohm only. So when we have replaced this 5 ohm and 2 ohm by a 7 ohm resistor, the current which shall be flowing from this battery, it will still be the same. That is, if we have an emitter over here, emitter measures the current in the circuit in that arm. So over here, whatsoever the emitter reading, initially it was there when there are 5 ohm and 2 ohm resistors they were there, and now when we have replaced 5 and 2 ohm by a single 7 ohm resistor, this ampere reading, this emitter reading will not change. Similarly over here also we see that is these two resistors they are also joined end to end. 7 and 5 ohm they are end to end, they are in one after the other. So whatsoever current enters over here, whatsoever the current goes over here, the same current will pass through these two resistors only. So once again we can use, that is when these two resistors they are in series, we can simply add them and we can find the equivalent resistance. So equivalent resistance of 7 and 5 ohm, 7 plus 5 that is 12 ohm. So it means we can replace this by a single resistance of 12 ohm. So as soon as you have a mixed combination of resistors questions, you can look for what are the resistances they are in series and what are in parallel, and accordingly you can proceed. Now we see that is this 12 ohm and 4 ohm resistors they are in parallel. The current which is flowing in this circuit from here, it has an option, it has a choice to go this way also and this way also, that it gets divided. It splits over here and both the arms they join over here. In parallel it is important, that is these arms they should be splitting together and they should be reuniting at the same place. Like over here, this path splits in two and both these paths they once again reunite at C. That's why 4 and 12 ohm they are the resistors in parallel. So what we can do is, if they are in parallel, we know that is how to find the equivalent. R equivalent is equal to 1 by 4 plus 1 by 12 is equal to, we can multiply it, divide by 3. So this is 3 by 12 plus 1 by 12 is equal to 4 by 12. We could have taken the LCM also. So 1 RQ, that is R equivalent is 12 by 4, that is 3 ohm. So the equivalent resistance of 12 and 4 which are in parallel, their equivalent resistance comes out to be 3 ohm. So what we can do is, we can replace these two, we can remove this 4 and 12 ohm and we can replace it by a single resistor of 3 ohm between B and C. Now once again we see that is 7 ohm and now 3 ohm, these they are in series. So far we know that is what we are trying to find out is, we are trying to find out what is the equivalent resistance between A and C, that is between these two vents. So now this 7 and 3 ohm they are in series. Whatsoever the current passes through 7 ohm, the same current will be passing through the 3 ohm resistor. So 7 plus 3 that is 10 ohm. So we can replace it by a single resistor of 10 ohm. This is 20 volt and now we have a single resistor. We can directly use Ohm's law, V is equal to I into R. V is 12 volt, that is potential difference. Potential difference across this resistor is 20 volt only. So we say 20 volt is equal to I, we don't know, that is what is the value of I into R. R in the circuit is 10 ohm. 10 ohm is the equivalent resistance of the whole circuit. So 20 is equal to this thing. So I is equal to, that is 2 ampere. Ammeter reading is going to be 2 ampere and the equivalent resistance between AC is going to be 10 ohm.